Today's learning goals, you can see, solve and check linear equations and use linear equations to solve real-world problems. Some of you, after you read section 1.5, you may be saying, there really wasn't anything new in there. I knew everything. But I hope you picked up on a few of the clues, shortcuts that were in the examples. So let's find out. First question, if I asked you, how do you eliminate fractions in an algebraic sentence? Would you say multiply each fraction by its denominator? Choice B, multiply the sentence by the LCD. C, erase them. Or D, change them to decimals. I know a lot of you do not like fractions as a choice or a type of number to work with. So changing to decimals is pretty popular, but we could eliminate all the fractions in an algebraic equation by multiplying by the LCD. Should be your first choice. So let's look at an example that does that so you can get a better idea of what it actually looks like. So with this equation, 1/3 D plus 1/5 D plus 273 equals D, I would ask, what is the LCD? Your denominators are a 3 and a 5, so you're saying what's the smallest number they both go into? If you're not thinking, think of that number now. 15 is that choice. So if 15 is the smallest, yes, there are others. They both go into 30. They both go into 45. And you can have higher numbers, but the smallest will keep your numbers workable in your equation as well. So if we now multiply each term in that equation by 15, you are going to see on the next line that your fractions go away and you should be left with some nice workable whole numbers. So 1/3 of 15, 1/5 of 15, 15 times 273, nice whole number. 15 times D already is a nice whole number. So let's look and see what remains. 5D plus 3D plus 4095 has to equal 15D. From here it turns into a regular algebra problem. Use your order of operations. 5D plus 3D, collect like terms. Move the 8D to the other side by subtracting or adding a negative. Dividing by 7, and you are done. You have your solution. You could check it back up into the original and it will make it true. So the D value was 585. We had one line basically we had fractions on. Once we got rid of it, it was nice, clean whole numbers that we finished with. So the same thing should be true. Well, what if it's decimals? A lot of you like your decimals because you have your calculator to use. However, we don't want to get dependent upon that. We want to know what to do and be able to work with decimals in our head quite easily. So let's look, how do you get rid of decimals is the next question. So eliminating them. Start thinking. Some people might say, well, eliminating decimals, I could just turn the decimal to a fraction, then use the fraction rule of eliminating decimals, the LCD, that you just showed me. You could. But remember, decimals are all based on powers of 10. So the question is, to eliminate decimal, you want to be looking at the largest power of 10 in the denominator, think of it that way. Or you could say, what is the furthest place value to the right of the decimal point that you have in your problem? Whatever that is, that place value is what you want to multiply by. So here's our example. 0.055x plus 0.07 times the quantity 500 minus x equals 32. So ask yourself, what is the largest power of 10 used in these decimals? So I'm 3 away from the decimal point, I'm 2 away from the decimal point. So 3 away uses 1,000 if we turn that to a fraction. 2 away only uses 100. So 1,000 is bigger, so I'm thinking if I multiply by 1,000, I could eliminate fractions or decimals in this problem. So the multiplier here will be that number 1,000. So look at it. If we multiplied in this first term by 1,000, that's going to be a move of 3 places to the right. We'd be looking at a 55. Moving the second term, or sorry, multiplying the second term by 1,000, 1, 2 to the right would put it there, but 3 more would make it a 70. You add that extra 0, so you'd have 70 times this quantity. And you don't have to multiply the 1,000 times the parentheses, because when you multiply it through the first term, when you distribute here, then it will get multiplied. And then 1,000 times the 32 on the other side. So when you finish that multiplication by 1,000, look at what you have remaining. Again, all whole numbers. In this case, the number's getting a little bigger. Not bad. You'd rather work with whole numbers than with decimals or fractions, though. So in order to solve this using order of operations, the distributing in the middle has to be done first. So 70 times 500 and 70 times a negative x should leave you with this line. Then collect like terms. You'd be at this. Move that 35,000 to the other side by subtracting. Then divide by 15, negative 15 on both sides, and you are left with x equals 200. Again, you could check that up into the original problem, make sure you haven't made any errors, but you would have a very clean, smooth way to get rid of decimals. And again, notice you only have one line that has any decimals in. Thereafter, everything is nice whole numbers. There was one more theorem in this section, and it was called the opposite of the sum theorem, put there to remind you about what you do in distributing and what you think of. So if we look over here first, we have the opposite of the quantity A plus B. So the opposite of a sum. Sum is the answer to an addition problem. So if we have the opposite of a sum where everything is positive to begin with, then we are going to have each term take on its opposite sign. So if I had A plus B, the opposite of that would be the opposite of A plus the opposite of B. One way to think of it. Up here, if our term was definitely had a subtraction or a negative sign in it, our sum would be A plus the opposite of B. Now again, you don't know what B is, whether it's positive or negative, but then again, you don't know what A is, positive or negative. So this could be two positive values, could be two negatives, could be one positive, one negative, and then after the addition, you're going to have a new result. But the key is, with this opposite sign out front, you always take the opposite of what's in the quantity. So think of it this way. If I start with an A and I take an opposite, I have the opposite of A. If I start with the opposite of B and I take its opposite, I then have a plus B. Because we know opposite of a negative is a positive. So the key is this sign, if it's just a sign out front, it always switches the value of what's inside. Now notice also, I was not saying, for example, over here, negative A plus negative B. I was reading it as the opposite of A plus the opposite of B. Reason for that? Because you don't know really what A is. And if A was a negative 3, then this would be the opposite of negative 3 or 3, and then whatever B is. So be careful. It's probably best, instead of reading this as negative A plus B or negative A plus negative B, better choice to say the opposite of A. Then your brain can switch it to whatever it needs to be, either positive or negative, in the problem. So bring any questions you have, concerns about how to get rid of fractions and decimals to class, because this will definitely be a shortcut and help in your work on solving equations. That's all for today. You should be able to do the problems from here.